Hello, this is my second video in a series on the solar system. Let me share my screen. This particular video is going to be about moons, etc. This is the second in a four-part series. The first one was on orbits, and it would probably be best if the viewer watched that one first because it has a little bit of a basis for the ones which follow. This is the second one on moons. The third one is on tidal forces. I expect that sounds less interesting than the others, but it's pretty good because it has some forces which are still currently working in the solar system that is good to understand. And the fourth one is on magnetic fields. So in this series, I'm not going to prove that God created the solar system. I'm just going to try to provide some understanding of certain aspects of the solar system that point to a created origin rather than a naturalistic origin. So, moons. In the solar system, there are more than 200 moons. In the inner planets of Mercury, Venus, Earth, and Mars, there are few. Mercury has 0, Venus has 0, Earth has 1, and Mars has 2. The ice giant planets of Jupiter, Saturn, Uranus, and Neptune, they all have many. And for those like me who like to think of Pluto as being a planet, because we grew up with it that way, Pluto has 5. Now, moons are usually divided into two categories, and they usually fit pretty well into one of these two categories. There are regular moons and irregular moons. Regular moons can be small or large, any size. Irregular moons tend to be small. Regular moons are very close to a planet in their orbit, and irregular moons are far. Regular moons have what's called a prograde orbit. That means they're orbiting in the same direction that the planet spins. Irregular moons can orbit in any direction whatsoever. The regular moons also tend to orbit right along the planet's spin equator. They're usually even within like 1 degree of the spin equator. But the irregular moons, once again, can have any kind of inclination at all. Regular moons have a circular orbit. Irregular moons are much more elliptical. Regular moons are tidally locked. That means they always show the same face to the planet. Irregular moons are not locked. In other words, they're just rotating. Now, those two about being locked and regular moons being locked and having a circular orbit, there's a reason for that, and I'll have to get to that in the next video on tidal forces. As far as proposed naturalistic origins, the idea is that regular moons developed along with the planet. That's why they're rotating the same way the planets spin. While irregular moons were captured by gravity. If you listen to my previous video, you probably know that both of those ideas are difficult and nearly impossible to do. In the present solar system, the way we're set up, we basically could never capture anything in a planet's gravity, nor could we create a regular moon that came off the planet. So they tend to like to point to some previous type of solar system which produced those things. But anyway, those are regular and irregular moons. Now, I expect as soon as I read this, for people who don't know, the question that would almost immediately come to mind is, what category is Earth's moon? And that's an excellent question because there are two moons in the solar system that completely defy the categories. And one is Earth's moon, and the other is Triton, one of the moons of Neptune. And so here's why. Regular moons can be any size. So Earth's moon is large. So that would mean we're a regular moon. Regular moons are close to a planet. Well, Earth it's kind of medium distance. It's a bit too far for a regular moon, but it's not quite so far as an irregular. Triton, being very large, it's also very close. So far, Triton sounds like a regular moon. Earth's orbit, the moon's orbit is also prograde, like a regular moon. Triton's is retrograde, so it's rotating the wrong way. Earth's moon, uh, it's not exactly inclined along our equator. It's 5 degrees off the ecliptic plane. That's the direction if you drew a line from the Earth to the sun. Um, but the Earth doesn't rotate that way. The Earth is tilted at a 23.5 degree angle. So Earth's moon is not rotating along our equator, and Triton is far off the equator. Our moon has something of an elliptical orbit. It's not way elliptical, but it's definitely elliptical, and it's not circular. Um, we are tidally locked like a regular moon, so we tend to have some categories which seem to fit regular and some which fit irregular. The proposed origin of Earth's naturalistic origin of Earth's moon is that it was formed by a collision. So let's talk a little bit more about Earth's moon. We'll start from the inner planets and work out, and we're the first planet with a moon. So Earth's moon is large. It's the fifth largest moon in the solar system, and it is the largest moon in relationship to its planet. It has a prograde orbit, but it's not very circular. It is tidally locked. It has the same side always facing the Earth. So when you see the moon, you're always seeing the same side. It's inclined about 5 degrees from the ecliptic plane, like we mentioned before. That's not on Earth's. Earth is tilted 23.5 degrees, and that gives us the seasons. In other words, our moon is lined up more with the sun than with the way the Earth spins. Now, for a naturalistic origin theory, the regular moon explanation doesn't work too well. The inclination is mismatched and the moon is too far away. The irregular moon explanation doesn't work well either. It's actually too close and too big to be an irregular moon. So the going theory right now in naturalistic terms is that there was a collision. And it went sort of like this diagram shows. The early Earth was hit by something really huge, hit real hard, created a disk of debris, and the debris coalesced and formed a moon. Well, I think, once again, if you have watched the previous video on orbits, you would be suspicious as to how that could even happen. How debris would come off the Earth and end up in orbit is kind of dubious. And the picture is a little bit misleading because the debris there is right close to the Earth, but the debris would actually have to be quite a ways away in order to not get inside what's called the Roche limit. So the debris would have to be far away, and then the whole idea of the debris coalescing is questionable. And I'm going to talk about that a little bit later when we get to some other moon. But anyway, that's the naturalistic theory of Earth's moon's origin. It doesn't work very well, I don't think. Our moon, happily for us, has some benefits for our life here on Earth. For one thing, it's large enough to give light. Second, its inclination it tends to lock in the Earth's 23.5 degree inclination. In other words, our inclination doesn't vary. It stays at that 23.5 degree range, and that allows us to have consistent seasons. Earth's moon also gives us tides, and the water tides support marine habitats and tend to clean up the coastline. Earth's moon also has the curious property of appearing the same size as the sun in the sky, and that allows us to have a really perfect eclipse where the moon blots out the sun exactly. This points to a design rather than a naturalistic origin. Now, the Bible doesn't have really anything to say about the creation of the other planets in terms of where they are right now is where they were created in the first place, but it does have something like that to say about the moon. It says God made two great lights, the greater light to rule the day and the lesser light to rule the night. The lesser light, of course, is the moon. It indicates that God created the moon in more or less the same condition that we see today. At this point, I want to introduce what are a concept of what's called Lagrangian points, because that helps to understand a few things. The Lagrangian points are points where the gravity of one body and the gravity of another body are equal. So between the Earth and the Sun, if you went, say, 1 million miles away from the Earth in the direction of the Sun, you would reach the Earth-Sun L1 Lagrangian point. You'd have to go 92 million miles further to get to the Sun, but that that's the point at which the Earth and the Sun would be pulling on each other in equal measure. And the Lagrangian points are interesting for some things in the solar system. You can do peculiar things, like you can put a satellite out there and it'll just sit there. It doesn't need any thrust. It just kind of stays there because the gravity is equal. And if you look at where the Lagrangian point is and where the moon is in this diagram, although the sizes are wrong, I believe I've got the perspective on the distance pretty close. The moon is about 80% the way closer to the Earth. So the moon is pretty far down in the Earth's gravity well. Regular moons will generally be closer to their planet than this diagram would show our moon being, while irregular moons would tend to be farther out. They would not be too close to their Lagrangian points, but they would be farther out than our moon. Than our moon. So let's move on to Mars. Here's a picture of Phobos and Deimos, the two Martian moons. They are very small. They're so small that the gravity is very small, and you could actually jump off those moons if you jumped hard. And you can also tell that they're not exactly round. That's also another feature. The gravity isn't great enough to pull them into a round shape. They have prograde circular orbits close to a planet along Mars's spin equator and tidally locked, so they totally fit the regular moon category. Phobos orbits faster than Mars rotates, so if you were standing on Mars' surface, you would see it appear to rise in the west and set in the east. That would be strange. Unfortunately, these moons look like asteroids visually, so most astronomers still think they are captured asteroids. In other words, irregular moons. But there's no way to get them so far down into Mars's gravity well into such a current low orbit. So it's a difficult thing to explain. Now, here's a fun fact about the Martian moons. These moons were described, maybe I should say predicted, in the book Gulliver's Travels about 150 years before they were discovered. The description in Gulliver's Travels of two Martian moons isn't exactly what Phobos and Deimos are, but it's really pretty close. Before I get to Jupiter, which would be the next planet, I should say something about the asteroid belt. Here's a good picture of the asteroid belt as far as showing where asteroids are. But the thing that's a little misleading about the picture is the density of the asteroids. All the asteroids put together only total up to about 3% the mass of our moon. So it's not like it's really crowded out there. The picture makes it look crowded, but it's not. The current form of the asteroid belt may be different from its form at creation. I believe it probably is. I'll talk about that in a minute. Notice also that we have another kinds of special asteroids. They're the Trojans of Jupiter. And there, the Trojans tend to be divided up into a group called the Trojans and a group called the Greeks. They're the green ones in there. And they rotate in a resonant orbit with Jupiter, either about 1/3 of the way around the sun in front of Jupiter or 1/3 away around the sun behind Jupiter. So let's talk about Jupiter's moons. 95 have been identified so far. There's 8 regular moons, 4 tiny inner moons, 4 large Galilean moons. The Galilean moons were the big ones that Galileo Galilei saw almost right away when he invented a telescope and looked at Jupiter. There are many irregular moons, and those are the pictures of the 4 large Galilean moons. Now, here's a really fun picture. And what are you seeing there? You're seeing the 3 inner Galilean moons, Ganymede, Europa, and Io. And they are in what's called a resonant orbit that's stable. You can look at it and see that Io rotates, and every 2 times it syncs up with Europa at the top of the diagram. Whereas Ganymede rotates twice as slow as Europa. And so every 4 times, well, every twice around, it interfaces with Europa at the bottom, and then it connects with Io up at the top. So it's a really peculiar dance of the moons here on Jupiter. This resonance is stable because there are 3 moons involved. If there were 2, this would actually not work. But there are many cases of resonance in the solar system. Like I said, this is stable. I want to show you an example of one that would not be stable. Let's assume that here's a picture of the sun and there's a picture of Jupiter, and we've got an asteroid that orbits the sun in exactly 1/3 the time that Jupiter orbits the sun. So there's an exact 3-to-1 resonance. Well, the problem is that when the asteroid gets closest to Jupiter, it's always on exactly the same side as the sun. And if that happens all the time, what'll happen is that the orbit will begin to deform a little bit. Like here, it'll get closer and closer to Jupiter when it gets to that point in the orbit. And finally, if it gets too close, it gets ejected from its orbit. And this actually happens. I created a model some years ago of the solar system, and if I placed a theoretical asteroid in that 3-to-1 resonance zone, it could get so close to Jupiter that when finally it broke 3, it might get flung anywhere. It could get flung into the outer solar system, or if it was just a teeny bit different, it might just get dislodged from its resonant place in the asteroid belt. Almost anything could happen with that asteroid if it started in resonance. And here's a picture of what are called the Kirkwood gaps in the asteroid belt. And it shows what's happened. If you look at that 3-to-1 line there, you'll see that there are no asteroids in that location 3-to-1. And it's because of the diagram I showed you before. They get ejected if they were to try to be there. Also at the 5-to-2 resonance and the 7-to-3 resonance, those are a little bit weaker, but they tend to get ejected from those locations too. So this is a case where I wouldn't say that the asteroid belt was created in exactly that form, but the resonance has caused it to be shaped into the current form that it is. Now we should come back to some Jupiter irregular moons and talk about groups. The irregular moons of Jupiter, many of them are divided into groups, and the groups are thought to have a common origin because they have similar orbits. One example here is called the Himalaya group, and I just clipped this out of the Wikipedia page on Jupiter's moons. And I circled over there, I boxed in red, the semi-major axis, that's how far it is from Jupiter. The orbital period, how long it takes to go around, the inclination and the eccentricity. Well, like that column on inclination, in a regular moon, that number can vary from 0 to 180. But if you look at this, you can see that everything in that group just varies from 27 to 29. So they're almost all the same. The distance from Jupiter is almost all the same. In other words, they're all very, very similar. So they're called irregular moon group. And they're named after the biggest moon in the group, which is Himalaya. So why is there a group like that? Well, what really most likely happened is that one moon became 9. It was due to a collision. Himalaya, though it's the biggest moon in the group, it's small, really, and it has weak gravity. The escape velocity from Himalaya is only 400 miles per hour. That would be slower than an airliner and vastly slower than any likely asteroid collision would be. So if something hit it, it could easily break apart with the parts escaping and becoming other moons. As far as I know, everyone agrees that that's what's happened. I'm sure that there's somebody that disputes it because there's always somebody that disputes everything, but that's what I think most everybody agrees has happened with Himalaya. But now, wait a minute. What does this mean for the accretion idea for the formation of the solar system? The accretion idea is that matter slowly came together to form these moons and planets and whatnot. But that's not really what happens in the real solar system. In the real solar system, small bodies collide and they're likely to break apart, not accrete. In 2022, NASA even flew a mission that intentionally hit an asteroid. We were experimenting with the idea of could we redirect an asteroid if we saw one was coming at Earth and it was be dangerous or something. So when we hit it, predictably, pieces broke off and are now flying free. So we've created several asteroids. So let's talk about Saturn's moon. Saturn always makes the prettiest planet to photograph because it's got these rings. Saturn, we've identified 146 moons, so that's the largest number of any in the solar system. Saturn also has the largest moon in the solar system, Titan, and its moons are in groups like Jupiter's Himalaya group. Now, the rings of Saturn are quite likely inner moons that got too close to the planet and broke up due to tidal forces. This picture is of the moons of Uranus, and this picture is taken from the James Webb Space Telescope. So that's not just a drawing, this is an actual photo. The James Webb Space Telescope, a real miracle of engineering, taking a good photo of things so far out and capturing so many moons in it. You can see in the photo that in the background, they're not just moons, there's a few galaxies in the background. But it shows some of the main moons of Neptune there. Excuse me, of Uranus. 13 inner moons, 5 major moons, and 10 irregular moons have been identified. Likely there are more small irregular moons that are just too small for us to see from here. Now, Uranus has an axial tilt almost perpendicular to the ecliptic plane. In other words, it's not orbiting, it's not rotating in the same direction that it orbits and that everybody else orbits. Instead, its rotation is head over heels, so to speak. So instead of rotating sideways, it's rotating up and down. Still, all its regular moons orbit along its equator, so they're also tilted to the ecliptic plane. This is a problem for a natural origin explanation because usually you want to explain Uranus having an unusual rotation by the idea that something big hit it and knocked it off its regular rotation. But for that to work, you'd have to have whatever hit it very early in its development before any of the regular moons came off, which is just sort of strange to imagine. So here's a picture of Neptune's moons. Now, this is a great picture of Neptune. It's really a gift that was taken from the Voyager spacecraft and put together based on images from the Voyager spacecraft way back in June 1989. And down at the bottom right-hand corner, you can see slowly moving up and to the right. That's the moon Triton. And you can even tell from that limited quality of the pictures that Triton is not moving in the direction that Neptune is rotating. We've identified 13 known moons on Neptune, but surely there are more. You have to remember Neptune is so far away, it's hard to get a good picture of it. There are 7 small regular moons. Then there's Triton, which is very large, 500 times larger than all the other Neptune moons combined. And then there are 5 small irregular moons. To say a few more words about Triton, it has a circular orbit close to the planet and it's tidally locked like a regular moon. However, its retrograde orbit, in other words, it goes completely the wrong way, inclined 156 degrees to Neptune's equator. So it is totally going the wrong way. So that's like an irregular moon. Now try to explain that in any kind of natural origin explanation. It's almost impossible to do so. Now I have to admit, from a creation-based explanation, to say that it was just created this way may be perceived as ad hoc. It's certainly a deus ex machina, but at least seems like if you start from a creation perspective, that would be possible. But Neptune's moon Titan is interesting and certainly hard to explain. So, conclusion of the moon story. The orbits of the moons in the solar system do not lend themselves to a naturalistic origin explanation. The present solar system may be somewhat different from that of creation. So certain things probably have changed since creation. We wouldn't insist that everything is exactly the same as it was at the very beginning. There are processes at work which would have changed things, like the Kirkwood gaps in the asteroid belt, the irregular moon groups, which were likely formed by breaking up of a parent moon. The rings of Saturn may be from the breakup of inner moons of Saturn. And the idea of moons breaking up, that doesn't fit well with an accretion origin model of the solar system. So I think that most of these points point more toward a design model of the solar system than a naturalistic model of the solar system. Small things are breaking apart, not coming together. Thank you for watching the video. That's the end of this one. I hope you can join for the next one, which will be on tidal forces.